All right, here we go with Chapter 4, Day 2 of your applications. So this is page 3 in your note packet, and we are working on identifying the number of possible solutions that you may have. Predominantly yesterday, the only thing I talked about was one solution, although you did have 2 homework problems that came up where they may have looked like this or this if you did it correctly. And actually, we're going to address that in one of your very few homework questions today. So this video should be quick. Your homework should be quick. So we're on page 3. So what we see on this one here is that I have one equation, 5 minus 3x. But when I solve this equation here, so if I subtract 15x from both sides, I get 5y equals negative 15x plus 25. And then I divide all of these things by 5. And I get y equals negative 3x plus 5. Well, if we look up here, actually this, when rewritten correctly in slope-intercept form, is negative 3x plus 5. It's the same line, just written in a different format. So when that happens, we come down here, you have infinitely many solutions. So we need to make a note of that. Infinite solutions. And that makes our graphing a lot easier. I'll go here at 5. And then our slope is negative 3x. So we go down 1, 2, 3 over 1. 1, 2, 3 over 1. 1, 2, 3 over 1. That'll be enough since we already know that we have this line right here. So there's only one line on that equation. So if I come down here on this one, when I add my 4x to both sides, I get 2y equals 4x plus 8. Divide both sides by 2. And I divide all of these things by 2. Y equals 2x plus 4. So you notice that's really similar to this. When they have the same slope, but a different y-intercept, this is what we have right here, over here now. So in a quick graph of this, so I have 2x plus 6. So I go 6, and I have a slope of up 2 over 1, which is also down 2, back 1. There's one of my lines. And that didn't quite work. That's better. Pretty close. And that's the 2x plus 6. Now I will do the 2x plus 4. And what you're going to see here is that all of these dots are just off by 1 because it's the same slope, just a different y-intercept. So now this one here, I'll try to make them look parallel. They're parallel lines. So in this case, we have no solutions. Moving on to applications. We can use algebra to solve a lot of real-world situations, and this is one of them. So you have 2 people reading a novel, and they have 14 more days to finish it. Monisha is going to read 9 pages a day, and Holly's going to read 20 pages a day. And you'll notice over here, you're going to see that they are currently on different pages. That is our starting point. So if we go back to last chapter, that is our y-intercept. So Manisha's already read 96 pages, and then she's going to read 9 pages per day. So her equation, if we just keep it with y equals 9x, 9 pages per day. So if x is equal to days, and then y is equal to pages read. And remember, she was already on page 96. So Holly is on page 6 of her book, but she's going to read 20 pages a day. So a little bit of a procrastinator, waiting towards the end there, only on page 6. All right, and it says, when will Holly catch up to her? So in order to figure this out, actually what we're going to do is make these two things equal. That will tell us when they would catch each other. So now I move my 9x. That leaves me with 11x plus 6 equals 96. Then I subtract 6, and I get 90 equals 11x divided by 11. And I get an answer of, we'll just round that to 8.2 days. On the 8th day, she's going to catch her. So who will finish it up first? Well, if they catch each other in 8 days, and we quickly check to make sure that that's not going to put us past the end of the book, which it doesn't. If we just did some quick rounding, 8 times 20 is 160 plus 6. It's 166 plus the 0.2, which is only a couple more pages. So no, they're not going to get to page 220. But what we do know is that once they catch each other, Holly's going to keep reading 20 pages a day. So to answer our questions, the first question says, when will Holly catch her? And this is a big part of your homework today. Holly will take 8.2 days to catch Monisha. And then who will finish first? Again, we said Holly. Because once they catch her, she's reading more pages per day. Holly will be done first. So a very similar problem down here. You're painting, Juanita's painting her house. She can buy either brand A and one paint roller, or brand B and a grid for the paint roller. So when would it be the same? Well, our first option, so we'll do y is equal to cost. And x is equal to gallons of paint, because that's $27 per gallon. So our total cost is equal to $27 per gallon. Or actually, I'm sorry, we're doing x, but you could do g there because that would make sense. Plus, you're going to buy one roller tray for $3. The other one, you're going to spend $25 a gallon, but $5 for a grid for your roller. And we're going to do the exact same thing. You get them into y equals mx plus b form, and we solve it. So we're going to set them equal to each other. So I subtract 25x because that's the smaller number. I like to work with positive numbers. 2x plus 3 equals 5. Subtract 3. 2x equals 2. Divide by 2. X equals 1. So what we're going to see is, when are they equal? Well, yeah, that makes sense now, after 1 gallon. Because if we plugged in 1, you would have 27 plus 3 and 25 plus 5. So then to answer the question, what's the better option if you're going to get 15 gallons of paint? Well, clearly, this is going to be brand B. Because they're equal after 1, and then 25 is less than 27. So that's it for the notes for today. Your homework is only on page 6. That's it. It's 2-story problems, just like we did here. You don't have to do any more graphing, but I do want you to do this. I want you to look back at your graphs, so you might have to pause this and write this down. Look back at your graphs from number 4 and 6 on yesterday's homework, which is on page 5. And using what we learned today about infinite solutions and no solutions, what makes those 2 questions unique? So you need to go back and look at number 4 and 6. And basically what I'm telling you, hopefully you pick up on this, is that one or both of them is no solution, and one or both of them is infinite solutions. So if you had one solution yesterday on number 4 and number 6, go back and figure out what you did wrong. But I want you to add this question. And when I grade your assignment, I'm going to be looking for this question. And if this question isn't on here, I'm going to bounce it back to you. So it says be specific. So I want you to write a couple sentences here about number 4, what's unique about number 4, and what's unique about number 6. And that is it for today, just those 3 questions. So have a good one.